the material before the second midterm. And the other 4 questions are long doing questions. This is all what refers to the systems of equations. So basically from 7.4 till 7.9 included. So the long doing questions will be on systems of equations. They will be at the end, so plan yourself correspondingly depending on how well you work with long or short questions. Short answer questions, they require writing, but they will be all half a page, not more. There is not much about doing this. Doing part is easy. It's about thinking. And multiple choice, again, you will have to pick up the right answer among the 5 answers and put this data in the table. You will have, as if no extra space for writing for this multiple choice, but you can use simply the space to the right from the conditions where you will be choosing your answer. So there is space on the right where you can write. Yes, please.
By table, do you mean something to fill out, or did we something else? Okay.
There will be a table questions from 1 to 10. 1, 2, 3, and so on, and you have to put here A, B, C, D.
Okay.
Your choice out of 5. Yes, please.
For one of the multiple choice questions, we won't have it so that there's like A and B for one of the answers?
That I don't know.
Okay.
You don't know?
Yes, please.
Is it going to be all theory, or are there going to be some calculations on the multiple choice?
No. They are all basically calculations based on the theory of reasoning. So the calculations are one step typically. But it's one step to find, let's say, for example, eigenvalues, but it's mental process to think which kind of the graph you will get as a result, right? So that's you have to know. That's why I'm saying these questions are a little bit doing, but mainly thinking. There is nothing covert, hidden. It's always extremely straightforward, but you have to know material perfectly. So there are no true and false where you will really have to go like this. These are multiple choice, but based on what you learn. Yes, please. No. But you will still have to do some work, because otherwise you will have no grounds to make it complete. If you can do it in your head, go ahead. We are writing in the room 2600, you cannot copy from your neighbor. It's a huge room. There will be space in between. Yes, please. Louder, please.
You get penalized if you put a wrong answer on the multiple choice?
I don't like this approach. I don't. But believe me, at the smallest sight of somebody skewing their eyes, that's a bad thing to do. Okay? So I'm not penalizing with -1s. I hate this anymore. But again, don't even think of looking into your neighbor's writing. So let's look a little bit into what we have to know. Direction fields. You will not be requested to draw the direction field, but you have to be very clear on what is meant by the direction field and which lines correspond to what. What are the qualitative solutions? What are the basic things which we did at the very beginning. Second one is linear equations and method of integrating factors. That you should know by now by heart, how you integrate linear equation. That's definitely not a doing part. It's definitely in your head. Separable equations. That's possibility on a short answer. And obviously, what do we recall? Some are linear, some are non-linear. And some solutions may be working, maybe not working. That's what we did in class and on the homework. Modeling. Modeling, we did quite a few problems. You have to know how to get to the equations from real life situations. Nothing beyond what I have been doing in class. Now, definitely you will not get questions on the theorems per se, but you will get questions which will require you knowledge of theorems. So definitely you have to be very sure how to find where solution is existing, where it's not existing. Exact equations and integrating factors. Again, small doing question, few lines you have to know how to find this integrating factor and how to prove that it works. Easy, we have been doing many of these problems. Euler's method, as I said, that's not on the exam. Now we come to the second order differential equations. Definitely you have to know how to build the solution, depending on the case of which route you get. And you have to be able, and it's the same for the linear equations, the same is here, you have to be able to predict what is the long-term behavior. Is your solution decaying? Is it going to infinity or negative infinity? These things you should be able to solve for.
Did you say long term or short term? Long term.
Long
Yeah,
term.
of course.
Short term, nobody cares. For short term, you typically have the solution, right? It's the long term which we are concerned with. So again, I'm trying to refresh your memory on limits and what do we do with this and how it looks like. What is the meaning of C1 near Y1 and C2 near Y2? So that's what you have to really think about. Method of undetermined coefficients, again, knowing how to build this particular solution of the system, of the equation. Variation of parameters, just more straightforward. Now we come to vibrations. That's what you have to know. You have to definitely know how to convert this simple problem with the spring and mass into the differential equation. Definitely kilograms and meters. No pounds and feet. I don't operate in that. Yes. That should not be too difficult for engineers. But you have to remember what is the equation like, right? Who is m, who is gamma. That you have to know.
Will you ask us to draw the graph?
Sorry?
Will you ask us to draw the graph?
Oh yeah.
Maybe.
Yes.
No.
That's a yes. It's a guarantee.
No,
She didn't prepare it.
not this, but you have to know what is undamped, damped, underdamped, overdamped.
Critically
These
damped.
things you have to know for sure. And possibly graphs. Now, power series, only basic stuff. Laplace transform. Yes,
For vibrations, are we going to have to know how to find like the frequency at which it attains its maximum amplitude?
no.
Oh, thank God. Where? Which one?
On the
Laplace
maximum
transform,
value.
we already did a
Of the
lot,
frequency.
so you have to know how to find Laplace transform of the function by definition.
That's what we already
definitely what you have to remember how to do. What is the definition? There will be formulas provided on the last page, but they're dead if you don't know what they mean.
So chapter 5, you're taking it off?
As I said, basic stuff. Nothing too complicated. I want you to spend time on doing the last questions. With the series, we already did doing stuff, so only conceptual questions. And the very basics. So, again, with Laplace transform, you have to know these Heaviside function, step function, delta function, how you go to find the inverse, and the direct Laplace transform. So these things, and both shifting theorems for sure. Again, they will be provided on the formula sheet, but you have to know how to apply them. Yes?
We have to know the convolution.
Yes.
Convolution.
Is the definition of Laplace one of the formulas that we get?
Yes, but again, as I said, it doesn't help if you don't know what it means. Who is who there? You have to be very clear what is the role of T, S. again, this exam is very strong conceptual understanding. Any doing in this first part is towards how much you understand who is who where.